So let's see the universally accepted and applicable shortcut first. So the first figure which I gave you was this. In this we had four small triangles, and here we had a number of small triangles. So I am generalizing it by taking many examples now. Now see, if you closely look at this figure, traditional counting is very easy in this case because you have 1, 2, 3, 4 small triangles and one big triangle, so 5 triangles are there. How you get to that answer 5, that is very important. Now see the method which I am going to tell you to count these 5 triangles. See, I have labeled the two parts of any one side, say this side. See, there are two parts here, and if you observe this figure, we have 1, 2, and 3 parts here. So on every side, we have 3 triangles. So 1, 2, and 3 on this base. On this base, we have 1, 2, and 3, these 3 triangles. On this base, we have 3 triangles. So these are symmetrical figures, and in this case we have on the base, if you see 1, 2, 3, 4, and 5 triangles. Likewise on other sides also you can see 5 triangles. So you can have any number of triangles like 2, 3, 4, 5, 6, and any number of triangles. So once you know the generalized method of finding the total number of triangles, then the magnitude of this figure will not matter. You can solve it in 5 to 6 seconds time only. How do we do this? Now see, these are numbers 1 and 2. So the first number 1 is to be written as it is. So I will not write this here, just to avoid any confusion. So this number 1 will come as it is. Now 1 plus 2 gives you 3. So we have only two numbers. So we have to write as if we are writing the cumulative frequency. The first number comes as it is, and then next number gets added to this to give you this sum. Now, after having done this, we have to write one more column here, column of numbers, and that column will be written from the bottom. So I'll write this first and this later. From the bottom, corresponding to 3, write 0. So for the first number at the bottom corresponding to this number, you have to write 0, and this number will come as it is here. This method of writing this column is also known as skip 1, write 1. So this is skipping 1. So I am skipping this 3 and writing this number here. Skip 1, write 1. And now add this column. 3 plus 1, it is 4, and 1 plus 0, it is 1, and again add the two sums, you get your final answer 5. I know it might look little bit tricky when you see it for the first time, but if you apply it here, now you will be feeling more comfortable. Now see, the first number is 1, so I'll write 1. 1 plus 2 gives you 3, and now 3 plus 3 gives you 6. So I have 3 numbers now. 1 comes as it is, and 1 added to 2 gives you 3, 3 added to 3 gives you 6. And now in the second column, you have to follow this rule. Skip the first, write the next. Skip the next, write the next. So skipping 1 and writing 1, and mind you, you have to start from the bottom. So from here, skip this, write this, skip this. So alternatively skipping and writing. This goes on, and now add, this is 6 plus 3, 9 plus 1, 10, and this is okay 3. So 10 plus 3 gives you 13. So there are 13 triangles in this figure. Now if you want to count it, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 small triangles, then 10, 11, 12, and the bigger one 13. So there are 13 triangles. So verified by the traditional approach. Now let's apply it here. Again the same method, and now this is going to seem more easier than before. You can observe here that we have five triangles on each side. So we have 1, 2, 3, 4, 5. So the first number 1 comes as it is. Now 1 plus 2 gives you 3. 3 plus 3 gives you 6. 6 plus 4 gives you 10. And then 10 plus 5 gives you 15. So I have written the cumulative frequencies, and now corresponding to 15 I have to skip right, skip right, skip, skip right, skip right, skip. This goes on starting from the bottom in the second column. Now add sum of all these numbers: 15 plus 10, 25 plus 10, 35, and sum of all these numbers 10 plus 3, 13, will give you your final answer: 48 triangles in this figure. Isn't that amazing? A small method, and you know how many triangles are there in this figure. Friends, this method can be applied to any larger figure also, in which there are 6, 7, 8, 9, even 10 triangles along each side of the larger triangle. You will get the accurate answer every time. Now, let us see another method of finding this. But mind you, the method which I am going to tell you is applicable only for even number of triangles on each side. So 3 and 5, we cannot apply the method which I am going to tell you to these. But we can apply it here because we have only 2 triangles along the side. So let's see how we can apply this second method. You will find it in some more videos on YouTube. The formula n into n plus 2 into 2n plus 1 upon 8. Now this formula can be used when n is number of triangles along one side. Very important that you remember, n should be even. So when n is even, you can utilize this formula also. So let us apply it in the smaller figure here. This figure has 2 triangles along one side, so n is 2. So if n is 2, that implies number of triangles will be, just substitute the value of n here, n is 2, then n plus 2, that is 2 plus 2, and finally 2n, 2n means 4, 4 plus 1 upon 8. So you have 2 into 4 into 5 upon 8. So 2 into 4, 8 gets cancelled and you get the required number of triangles, that is 5, which is same as obtained in this figure. Friends, you can go on and try this formula for different figures. Let us have n as 4 because I need to take even number of triangles, so I am taking n as 4. So if n is 4, then number of triangles is 4, that is n, into 4 plus 2, that is 6, into 4 2s are 8 plus 1 9 upon 8. So 4 cancels out 2 times and 2 cancels 3 times, thereby giving you 27 triangles as the answer for n equal to 4. You want to verify? Let's see with the other method also. So if there are 4 triangles like this on one side, so I am not drawing the rest of the figure, it should be something like this. Now if there are 1, 2, 3, 4 triangles along one side, then the other method which I told you will have 1, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, then skip 1, write 1, skip 1, write 1. So this will be 10 plus 6, 16, plus 3, 19, plus 1, 20, and 6 plus 1, 7, that is 27 triangles. So the same answer which we have obtained here, but this method can be applied only when n is even. So I hope you have learned the two methods of counting the number of triangles in such a figure, and it's a very important concept for all competitive exams which include these type of questions.